morning, students. Today we are going to discuss for standard 11th computer application lesson number 2, number systems. So already we have discussed about what is number system, the introduction of number system. We discussed about the term data, where the term data comes from. The term data comes from the word datum, which means raw fact. And we discuss an example. For example, name is equal to Rajesh, age is equal to 16, class is 11th standard, mark 65, and subject is computer science. So this is a raw fact, and all these are called as variables, and these are called values. So we are assigning a value for a variable. Okay, so once after this has been processed, this is a raw fact, and once if this has been processed, then you will get the information such as Rajesh is 16 years old, studying in class 11, has secured 65 marks in computer science subject. Alright. Then how data is represented in computer. So it handles data in the form of zeros and ones, whereas 0 and 1 is called as machine language, and 0 or 1 are called as binary digit, and this binary digit consists of only two numbers, that is 0 and 1. So therefore the study of data representation in the computer is very important. Okay, so we come across the word called as the term called as bit. Okay, so this term has been coined from the word binary digit. So if you can see here, binary, from the term binary they have took bi, and from digit they took t, so we get bit. Then we studied about a nibble. So a nibble is a collection of 4 bits. Then a collection of 8 bits is called as a byte. So I already said this is a 1 mark question. A nibble is a collection of 4 bits, and a collection of 8 bits is called as a byte. Then this may be asked in a 2 mark question. What do you mean by word length? So we saw this word length refers to the number of bits processed by a computer CPU. Alright, so nowadays we are making use of 32-bit computers and 64-bit computers. So mostly nowadays we are making use of this 84-bits computer. Then, so how data is represented? So starting from bit, then nibble, byte, kilobyte, megabyte, gigabyte, terabyte, and you have exabyte, zettabyte, and yottabyte, like that. Okay, so here in this, what is very important is you should know 1 kilobyte represents 1024 bytes. Okay, so this is another one example. So 1 kilobyte represent 1024 byte, that is 2 to the power 10. And if you see this memory size chart table, and from this memory chart table they may ask you 1 mark question. For example, they may ask 2 power 70. Okay, so 2 power 70 is zettabyte. Yes, they may ask even 2 power 30. So what is the name of the memory is gigabyte. Okay, so you just go through this. So it starts from 2 power 10, 20, 30, 40, 50, 60, 70, and 80. So kilobyte, megabyte, gigabyte, terabyte, petabyte, exabyte, zettabyte, and yottabyte. So we already discussed in the previous slide that 1 kilobyte represent 1024 bytes. Okay, so this is here, so it is denoted as 2 power 10. So here next thing is the most commonly used coding system is the ASCII code. So this is ASCII code. So ASCII code is nothing but for each and every alphabet, for each and every special character, for each and every numbers, this American Standard Code for Information Interchange. So this is also another 1 mark question, you just make a note of it. So American Standard Code for Information Interchange. Alright, so they gave certain value for each and every alphabets, for numbers as well as for special characters. See, for example, for blank space, the ASCII value is 32. Okay, then the range of lowercase alphabet is, that is from small letter a to small letter z, the range of lowercase alphabet is from 97 to 122. Then the range of ASCII values for the uppercase alphabet is starting from 65 to 90. So all these three things are very, very important 1 mark question. They may ask even in public exam too. Then the next thing is different types of number systems. Okay, so this question is a 5 mark question. What are the types of number system do we have? So this is a very important 5 mark question. So let's look at this chart. So number system can be classified into decimal number system, binary, octal as well as hexadecimal. Okay, so 4 types of number system we are making use of. So in the first one, decimal number system, it contains of numbers starting from 0 to 9. So 0, 1, 2, 3, 4 like that, it goes on up to 9. So in total it will have 10 values. So decimal contains 10 values starting from 0 to 9. Then the second one is binary number system. Binary number system consists only 2 values, that is 0 and 1. Then octal consists of 8 values starting from 0 to 7. And hexadecimal value contains 16 value starting from 0 to 9 and capital letter A to capital letter F. So that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and A denotes 10, B is 11, C is 12, D is 13, E is 14 and F is 15. So in total it will have 16 values, 16 numbers. Okay, now let us discuss one by one in detail. So a numbering system is a way of representing numbers. The most commonly used numbering system is decimal number system. So this is another 1 mark question. The most commonly used numbering system is decimal number system. And other number systems are binary, octal, hexadecimal number system. Each number system is uniquely identified by its base value or radix. So this is another 1 mark question. Okay, so each number system is uniquely identified by its base value or radix. See, for example, for decimal number system, the base value or radix will be 10. For binary number system, the base value or radix will be 2. For octal, it would be 8, and for hexadecimal, it would be 16. Clear, students? Now the first one is decimal number system. So in decimal number system, we will have 10 digits starting from 0 to 9. Then in the positional number system, each decimal digit is weighed relative to its position in the number. This means that each digit in the number is multiplied by 10 raised to the power corresponding to that digit's position. Okay, we'll see an example. See here. So this is an example for decimal number system. So here they have given 1, 2, 3 to the base 10. So this is called as base value or radix. So now what they are telling is, So if you see the last point here, they have mentioned clearly that each digit in the number should be multiplied by 10 raised to the power corresponding to that digit's position. Okay, so if you see this example, so each digit is multiplied by 10. See, for example, 1 into 10 to the power of 2. Okay, so this power is nothing but the weight of each number. See, for example, 3. So always start the power from right to left. Okay, so from right to left. So for 3, the weightage is 0. For 2 it is 1, and for 1 it is 2. Okay, so 3 into 10 to the power 0 plus 2 into 10 to the power 1 plus 1 into 10 to the power 2. Alright, so here anything to the power 0 is 1. So it may be 5 to the power 0, or it may be 2 to the power 0. So anything to the power 0 is considered as 1. Okay, so 3 into 1 plus 2 into 10 plus 1 into 10 square is 100. So multiply this 100 plus 20 plus 3. So you will get 123. Okay. Then, so in binary number system there are only 2 digits, namely 0 and 1. The numbers in the binary system are represented to the base 2, and the positional multipliers are the powers of 2. The leftmost bit in the binary number is called as the most significant bit, which is called as MSB, and this MSB is an 1 mark question. So MSB is most significant bit, and if you can see here, so this is the left side, this is right side. So I already said we should always start from right to left. Okay, so the leftmost bit, so see here, the leftmost bit in the binary number is called as most significant bit. That is, it will have the largest positional weight. Okay, I already said no, each number will have the positional weight. See, for example, this positional weight is 0, 1, 2, 3, 4, 5, 6 and 7. So this most significant bit will always have the largest positional weight. And towards your right side, this is called as LSB, which is least significant bit, and it always has the smallest positional weight, because when you are starting from right to left, the least significant bit will have the smallest weight, that is 1 power 0. That is, this is 1, this 1 will have the least positional weight, that is 0. The most significant bit will have the largest positional weight. Here it is 7. So 0, 1, 2, 3, 4, 5, 6 and 7. Then let us see another one example for binary to decimal conversion. Okay, so here they are given a binary number 1101 to the base 2. So once if you see the value with the base value 2, you should tell that this number is a binary number. So now we are going to convert this binary number to decimal number. Alright, so again start from right to left with its positional weight. So 1 into 2 to the power 0 plus 0 into 2 to the power 1 plus 1 into 2 to the power 2 plus 1 into 2 to the power 3. Alright, so once if you multiply this, see here 2 power 0, anything to the power 0 is 1. Alright, so 1 into 1 is 1. So 0 into 2, 2 to the power 1 is 2. So this will automatically become 0. Okay, so 8 plus 4 plus 1 is 13 to the base 10. Why here we are putting the base value as 10 is because we are converting binary number to decimal number. So decimal's base value is 10. Alright children. Okay, then the next one is octal number system. So octal number system uses digits from 0 to 7. So in total octal's base value or radix will have 8. Okay, see here an example, the octal sequence 547 to the base 8. So here the radix value or the base value is 8. So this is called as an octal number. So now we are going to change this octal number to decimal equivalent. Alright, the same procedure, again start from right to left, the positional weight. So 7 into 8 to the power 0 plus 4 into 8 to the power 1 plus 5 into 8 to the power 2. Alright, so anything to the power 0 again here, so 1. Alright, so multiply it. So answer would be 64 into 5 is 320 plus 4 8s are 32 plus 7. So answer will be 359 to the base 10. So converted octal number into decimal equivalent. Then the last type of number system is hexadecimal number system. So here the hexadecimal number system, the base value would be 16. Alright, so the sequence of the number will be from 0 to 9, and the remaining 6 symbols are taken from the first 6 letters of the alphabet, where A represents 10, B is 11, C is 12, D is 13, E is 14 and F is 15. So totally you will have numbers 0 to 9 as well as alphabet starting from A to F. So let's see an example for it. The hexadecimal sequence of 25 base 16. So here the base is 16, so this is an hexadecimal number. So convert hexadecimal to decimal equivalent. So same method, so 5 into 16 power 0 plus 2 into 16 power 1. So this is least significant bit because it has a lower positional weight, smaller positional weight, and this one is a most significant bit, it has the highest positional weight. Okay, so it may be 1, 2, 3 or 4. So it depends upon the number which is given here. Okay, so but the least will always be 0. Alright, so this 16 into 2 is 32. So anything to the power 0 is 1. So 1 into 5 is 5. So total 37 to the base 10. Okay children, so the 5 mark gets over by here. Okay, so we discuss about the 4 types of number system, different types of number system, that is decimal, binary, octal as well as hexadecimal. Okay, so we discuss with an example. So we discuss all the 4 types of number system. So that is a very important 5 mark question, so be thorough in it. So now we are moving to the next subtopic, that is number system conversion. Okay, so number system conversion, it is in 2.4, and in that 2.4 the first number system conversion is decimal number system to binary number system conversion. Alright, so here they are given two methods. So first method is by repeated division by 2. So first method is repeated division by 2, and the second method would be sum of powers of 2. Okay, so in these 2 methods you can do any one method which is easy for you, and it's my suggestion is to follow repeated division by 2. Okay, the first method will be easy. Okay, so the first method is repeated division by 2. Any decimal number divided by 2 will leave a remainder of 0 or 1. Repeated division by 2 will leave a sequence of zeros and ones that become the binary equivalent of the decimal number. Suppose it is required to convert the decimal number n into a binary form, divide n by 2 in the decimal number system. We will obtain a quotient called as n1 and remainder called as r1. So we will see it with an example where r1 can have a value of either 0 or 1. Okay, so now see this example. So 172. Okay, so this is called as repeated division method by 2. Okay, because we are going on dividing the number by 2, and this is called as n, and this is called as here. So the decimal number n, so this n is nothing but the number which is given here, 172, or it may be 4215 or any other number. So once when you are dividing this n by 2, you will get n1 as well as r1. Okay, so you will get a quotient as well as you will get a remainder. So n1 and an r1. So again you should divide this n1 by 2. So again you will get another n1 and r1. Okay, so you should go on divide this number by 2, and that is what given here. So you will obtain the quotient n1 and a remainder r1, where r1 can have a value of either 0 or 1. So always your remainder will have the number 0 or 1, because we are converting the decimal number to binary number. So binary will always have only two numbers, that is 0 or 1. So this process should be repeated until the quotient becomes 0 or 1. So here the quotient is nothing but your n1. So the process should be repeated until your n1 becomes 0 or 1. I hope so this is very clear to you. So write the final answer starting from final remainder value obtained to the first remainder value obtained. Okay, so how you should write the answer is, so this is the final value obtained. Okay, so the final value obtained is 1 and the remainder is 0. So starting from the final value, you should write till the first value which is obtained. Okay, so always you should write the answer from bottom to top approach. So see here, 1 0 1 0 1 1 00. Clear? So always you should write the answer from bottom to top, that is from last obtained value to the first obtained value. Clear? So this is called as repeated division by 2. Okay, so this is the method 2, which is sum of powers of 0, and the same. Okay, so see, 22 to the base 10, you will get 10110 to the base 2. And even if you do this number 172 by the method called as sum of powers of 2, you will get the same answer, which is here 10101100. And here you should make a note of it, that is, see, once we are dividing a number by 2, and if the last value is 0, that is your final answer, your final quotient is 0, it is not necessary that you should put the 0. Okay, it is not necessary that you should add 0, because preceding 0 is not necessary. Actually the answer is 0 1 0 0 0 0 0 1 1 1 0 1 1 1. That should be the answer. Okay, since you are getting 0, preceding 0 is deleted, so therefore the answer starts from 1 0 0 0 0 0 1 1 0 1 1. Clear? So here you are getting n1 as 1, so here you should not delete it. Okay, so here you should add this 1. If suppose here you are getting 0, then it is not necessary to put 0 here. Clear, children? The next number system is decimal to octal conversion. So to convert decimal to octal, repeated division by 8. So in the last method we saw repeated division by 2, because we converted decimal to binary conversion. So for binary you should you should do this repeated division by 2, and for octal, by decimal to octal, you should do repeated division by 8. So now see this example. So the example number here is 100. So we are going to convert this decimal number 100 to the base 10 to octal conversion. Okay, so this is as same as your decimal to binary, but instead of repeated division by 2, here we have to do the repeated division by 8, because we are going to convert it into octal. Alright, so here 100, so divided by 8, see here 100 divided by 8, so you will get 12 times, so 12 into 8 is 96, so 96, so remainder is 4. Okay, so because we are having 100, so 12 into 8 is 96, so your remainder is 4, and then again divided by 8, so 1 times is 8, remainder is 4. Okay, so we can't continue this because here we are getting the n as 1. So now we should write the answer from bottom to top approach. So your answer will be 144 to the base 8. Alright, so your answer is 144 to the base 8. And then the next one is decimal to hexadecimal conversion. So decimal to hexadecimal conversion, and this is also the same method. So instead of repeated division by 2 and repeated division by 8, here it is hexadecimal, so we have to divide the number by 16. Alright, so 10767, so divide by 16, 672, so your remainder will be 15. Again divide by 62, so 42, remainder is 0. Again divide this 42 by 16, so 2 times, remainder is 10. So you can further divide it, because here itself you got least number. Okay, so preceding is 0, so therefore your number is 2. So here, from here your answer will start. Okay, so 2, 10, 0, 15. Since this is hexadecimal number, we are getting 10 and 15 here. So we already said that in hexadecimal only numbers from 0 to 9 you will have, and instead of 10 you will have A, instead of 11 you will have B, 12 C, 13 D, 14 E, and 15 is F. So here the remainder is 10. So what I should do is I should convert this 10 as A. So 2 A 0, and here it is 15, so 15 is represented as F in hexadecimal number. So 10767 base 10 decimal number, after converting it into hexadecimal, your answer should be 2A0F. Clear, children? And this conversion of fractional decimal to binary we will see in the next class. So until this, go through the video thoroughly. You just have a rough notebook and work out the problems by your own, and if you have any doubts you can clarify it with me on your next class. Okay, thank you, children.